All right. I don't want to sound like a broken record, but was the quiz exactly what I told you it would be?
Yes.
Okay, so I'm going to say this one more time. We're going to do 3 practice tests. That's what the test is going to look like. Just like those, right? So we're going to be ready. We're not going to be nervous. We're not going to be panicking. We're going to be ready because we know exactly what we need to know. Okay, so here we go. We are on P7. And it's problem 3, and it's a ball being thrown off the top of a building. And when will it hit the ground? Now, this formula that you are not responsible for memorizing, you will be given the formula if you ever need it. It's called the projectile motion formula. And projectiles are things that are thrown through the air. And this describes how high the object is after a certain amount of time. So, I will give you the formula, but I will not tell you what everything stands for. So I'm going to tell you now, and then you need to learn that. This right here is the height of the object. Remember, we're throwing something through the air. So this is the height of the object at time t. So whatever the t is, 1 second, 2 seconds, 3 seconds, this formula, this number right here is going to be the height of that object. T is time in seconds, so I'll just say seconds. There's another t, same thing, that's a time. So if we said how high is the ball after 1 second, t would be 1 second. This guy right here is the initial velocity. You will often see of the object. Remember, we're throwing it through the air, so that velocity that we're throwing it with. In physics and math, a lot of times you'll see a subscript of 0, V with a little subscript of a 0. That little subscript at 0 always means starting, initial. So that's the initial velocity. Then this guy is the initial height. So remember, this was the height after 2 seconds or something. This is the starting height. So like if I am throwing the ball, the starting height would be like 5 feet. If we're dropping it off the top of a building, then the starting height is whatever, 15 feet or however tall the building is. Got it? Okay, so what you need to do now is read the problem and come up with the equation that we're going to use specifically for problem 3. Okay? So what does it say? A ball is thrown off the top of a building 12 feet tall with an initial velocity of 18 feet per second. So my equation, and if you don't want to do this, you can say h. You can say h equals, if that's easier, height. It's height. So if you'd rather not use the function notation, s of t, f of x, you can just say height, equals negative 16t squared. That part never changes. Now, next comes, what's our initial velocity? 18, so that's going to be 18t. Please don't forget there is a t hooked to that. And what's our initial height? 12. So here is our equation that we are going to use for all of our problems in number 3. All the questions in number 3 are going to use that equation. Okay? Now, when will the ball hit the ground? Now, you guys, I want you to look carefully. I know you're used to seeing equations that have y's and x's. This one has, this is h, has an h and a t. So your variables are height and time. Every time you do one of these problems or read a question, they're either going to give you the height or they're going to give you the time. They're going to give you one of these. You're going to either plug a number in here or you're going to plug a number in here. Now, the question says, when will it hit the ground? Well, when is time, isn't it? So I am looking for the time. What's the height of the object? Remember, it is on the ground. So what's its height? 0. So for question A, you're going to put a 0 here for the height, and you're going to find the time.
Here, if we use other variables,
Nope, you can use whatever you want, because in a minute I'm going to go to my calculator, and then I'm going to have to use Y's and X's, because that's all I've got on my calculator. Okay? Alright, so I'm going to find out when this ball hits the ground. Alrighty? So I'm going to go to Y equals, and I'm going to type in this equation right here. So you don't put the 0 in there, you're just going to type in this guy right here. So negative 16x squared, please use x, please use x. The t variable on your calculator is something entirely different. That will be a disaster if you try to use that. Now, I'm going to go back and zoom 6 because I had my thing messed up. Here is what I got when I typed that in and hit graph. Remember, we type it in and hit graph. I got something that looked like this. Anybody else get something that looked like that? I zoom 6. So I use a standard window like a zoom 6 just gives you a regular piece of graph paper. Nothing weird about it, just a regular piece of graph paper. Now, you have to be able to interpret what's going on. First of all, does it make sense that your picture went up for a while and then it disappeared, but then it came back down? Does that make sense? Yeah, because what did we do? We threw a ball off the top of the building, and isn't going to go, I mean, I'm assuming you're throwing it up into the air. It's going to go up for a while, and then eventually it's going to come crashing back down to earth, right? This is the point that you need, because this is like the ground. That's the x-axis, and that's where the ball hit the ground. So we need to find that point. Say, we've already done this, let's do it again. We go to second, calc, that's the trace button. Okay? And then we pick 0, number 2 option, that's 0. And then the calculator is saying, where's your left bound? Now, you should see a cursor. If you don't, look down at the bottom of the screen. That tells you where your cursor is. Mine is clear up here. So I'm going to use my right arrow button. Oh, actually, I'm sorry, left arrow button. Oh no, I want right arrow button. I read first time. Use my right arrow button. Whoops, there it came. And it came, finally I saw it. It was up there for a while and it came down. Finally I saw it right here. And press enter. And then I find my right bound, and then I do my guess. And see if you came up with 1.595 as your X value. Anybody else get that? Good. So when does the ball hit the ground? 1.595 seconds. That's when the ball hit the ground.
How did you know to look on the right side instead of the left side?
Well, that's a good question, Kate, but I want you to think about something. Here's the y-axis, right? So whatever this point, isn't it a negative value?
Okay.
And can time be negative? No. So I gotta be positive. There is another x-intercept over there, but it's an extraneous route. It doesn't even make sense in this problem, right? This is the ball on the building, so we really don't even need this part of the picture. This is really the path of the ball, would you agree? Okay, next. when will the ball be 15 feet above the ground? Now remember, the formula in the box is the one you're using for every part of this problem. So we're using this same formula now. And I'm either gonna plug in a height or I'm gonna plug in a time. So read the question. When will the ball be 15 feet above the ground? Does the 15 feet go for the height or does it go for the time? Height, right? Isn't 15 feet a height, not a time? So I'm gonna, for question B, I'm gonna have 15 equals negative 16t squared plus 18t plus 12. Now be careful. Some of you are typing already, and that's fine. What are you typing? What are you putting into your calculator? Well, there are two ways you can do it. Remember, this original picture you had is a picture of this equation right here, right? So isn't that the same thing as this right here? So that picture is right now in your calculator. Somewhere up here, this was 12, because that's how high the building was. Somewhere up here, would you agree there's a 15? So I'm gonna go back to y equals, and I'm gonna put my first equation in there. My first equation is just staying from the last problem. And then for y2, I'm gonna put in 15. Then I'm gonna go to my window right here in the top row. So for y2, I just typed in 15, the number 15. And now I'm going to my window, and for y max, that's how high my graph is going to go, I'm going to put in 20 and hit graph. Now you should see something that looks like this. You should see your parabola, only now you see the whole thing, and you should see this line coming across if you set it up like I told you to. These 2 points are where the ball is 15 feet above the ground. Would you agree with me? So once on the way up, it's 15 high, and then once on the way down. Okay? Now, this time, I am not looking for this. This is an x-intercept. I'm not looking for that. This time I'm looking for where my parabola crosses my line, right? I'm looking for the intersection. So I'm going to do second, trace, 5, option 5, intersect. And then just like before, you have a cursor, right? You need the cursor to be somewhere to the left of this point. Mine is like right in here. Perfect, that's perfect. So I'm gonna press enter. Now I gotta move my cursor so it's to the left of that point. Boy, they're really close together. I got 0.203. Anybody else get that? This is kind of tricky, so I'm gonna have you make one more change to your calculator just to maybe help you do this. Go back to your window. If you had trouble finding that, I understand that. Let's go back to our window. And for x min and x max, I would like you to set those at -1 and 3. So x min, go to window right here, and set x min at -1 and x max at 3, and then hit graph. Does that help a little bit? Open that up, spread those points out. It's the same picture, it's just not so squishy up now anymore. All right, so now I'm gonna find this point right here. Everybody, if you really got lost in there, pay attention. You need to know how to do this. This is a test question. You need to know how to do it. So we're gonna find that point right there, okay? Now that's a point of intersection. So second calc intersect. Now my cursor happens to be flashing right here, right? That's not where I want it. I need it to be to the right, or excuse me, to the left of the point I'm looking for.
I'm not gonna be here on Wednesday, so I'm gonna miss your test.
I don't think our test is Wednesday.
It's not?
No, you have some homework due Wednesday.
I'll turn in for
Okay.
that.
Okay.
Okay,
Yeah.
sorry, I thought, wait, when's our test then?
I'm not sure yet. It depends how long we get through the review.
Oh, gotcha.
Okay? All right. So I need to find this point. So my cursor needs to be, here's the point I'm looking for. My cursor needs to be over here on the left side. So I'm going to use my arrow button and I'm just going to move my cursor. Now mine's over here. Just has to be over here somewhere. Mine happens to be right here and I'm going to press enter. Now my cursor needs to be on the right side of my hand. It needs to be over there somewhere. So I'm gonna press my arrow button, my right arrow. It's over there, anywhere over there. And then put the cursor in between. So get close to that point if you can. And somebody tell me what you got. What'd you get for that one? Point? What? 922. Point 922. Okay, we're gonna do another example, guys. We'll do another example. But first we gotta finish this one. So what is the answer to question B? When will it be 15 feet above the ground? When t is 0.203 seconds, or when t is 0.922 seconds. These are the 2 points when it's exactly 15 feet above the ground. What if we wanted to know when it was more than 15 feet above the ground? When is that? Wouldn't that be in between these two numbers? The whole time from 0.2 to 0.9, it's higher than 15, right? Perfect. Last question for number 3. How high is the ball after 1 second? Now remember, every part of this problem comes back to this equation. You will always either plug a number in here, like we plugged in 15 somewhere, we plugged in 15, or you'll plug a number in here. 1 second. Where does the 1 go? Does the 1 go in here for the height, or does the 1 go in here for the time? Time. So, my height is going to be negative 16 times 1 squared plus 18 times 1 plus 12. How high is the ball after 1 second? 1 is your time. Put 1 in right there. Do the math, and that will tell you how high it is. So 1 squared is 1 times negative 16, 18, and 12. What does that work out to be? 14 feet. So after 1 second, 1 second would be like right here, the ball is 14 feet above the ground. Remember, in between here, it's 15 feet above the ground. So after that, after 1 second, it would be only 14 feet. Okay. One more, we're gonna do the same thing with a different equation, same problem, same formula, same everything. So this time, let's really pay attention and try to stay on top of it. Here we go. I erased my general formula off the board, but I think I wrote it down again. Yeah, for problem 4. So for problem 4, what is going to be our equation? Remember, if S of t confuses you, call it h or y. In your calculator, it's going to be y. What is the height equal? Negative 16t squared plus, okay, now I am doing problem 4. what's my V sub naught, what's my initial velocity? 32. And what is my S sub naught, which is my initial height? 0. Why? Yes, why? It's on the ground. So you can put plus 0 or you can just not put anything. I think it's, personally, it confuses me to put plus 0. If it doesn't, you can do that, it doesn't matter. The ball's on the ground. So the initial height is 0. It's like the place kicker, like a kickoff in football when they, like the ball is on the ground when they kick it off. That would be the same kind of situation. Okay, so there's my equation that I'm using for all these problems. Number 1, when will it hit the ground? So remember, in your formula, you have 2 variables. You have a height and you have a time. When will it hit the ground? Is that, are you looking for a height or are you looking for a time? When will it hit the ground? You're looking for a time, which means you must have a height to plug in. When does it hit the ground? What height am I plugging in? 0. So this equation is going to be 0 equals negative 16t squared plus 32t. Now this one is definitely doable without a calculator. This is an easy one compared to the last one, but we're gonna go ahead and do it on our calculator just for practice, even though we could do it without a calculator. Okay, and I'll show you how in a second. But first, let's go back to y equals. Clear out all the old equations. You don't have any equations in there from the last problem. And you're going to type in this equation right here. So you're going to type in negative 16x squared plus 32x. Now I want you to zoom 6 and graph. Now you have to get used to either dealing with the weird graph that came up or knowing how to fix it. But here's what I want you to understand. Did you get something like this? It's kind of, again, it's kind of squishy in there, but did you get something like that? So what's going on here is the ball has gone up into the air and it's come back down. What point am I interested in? That one right there, aren't I? Isn't that when the ball hits the ground? So that's called a 0. So I am going to second trace, second calc. Option 2 is 0. That's what I'm looking for this time. This is the point you want. So think of, there's no line there, but think of, there's the line. You need to have your cursor to the left of that. So just set your cursor over here somewhere. It doesn't matter where. Just get it over there and press enter. Then you gotta move it to the right of the point, which my picture's kind of hard to tell, but that would be down here somewhere, to the right of that point. So move your cursor till it's over there. And then put it in between. You should have gotten that point as 2, 0.
So you keep getting the syntax error, but I'm writing
So you typed your equation in wrong. Syntax error means you typed your equation wrong.
No, okay, redo it again.
Yeah, I know, I just retyped it.
You're gone.
My guess
You
is
are all gone.
this is so honest.
Okay,
Okay, so when does the ball hit the ground? It hits the ground after 2 seconds. So the answer to question A is it hits the ground after 2 seconds. Next question. How high will it be after half a second? How how high will it be after half a second? So we go back to our equation. How high will it be? Isn't this what I'm trying to find now? Which means the 1/2 goes into t. What's the unit on a half? Half of what? Half a second? Isn't second time? So feet's gonna go here. If you have a feet number, it goes here. If you have a seconds number, it goes here. So h equals -16 t squared plus 32t. You have to put the 1/2 in for all of the t's. If you're doing this on your calculator, if you're typing this in on your calculator, you're gonna type 0.5 and square it, and then times -16. And then plus 32 times 0.5. You should get 12. So however you typed it in, if you got 12 feet, you got it right. If you got something different than 12, you did not type it in correctly. So you wanna take 1/2 and square it, and multiply it by -16, and then add to that answer 32 times 1/2. 12 feet. And then finally, when will the ball be 20 feet high? So before we go to graphing, I want you to understand, you got this picture, ball's going up and coming down, and somewhere up here, it's 20 feet high. So I wanna know, when is the ball 20 feet high?
Do we just put that in the watt or the
So I'm gonna put in a new equation now. I'm gonna leave my original in there. Cause this is, so 20 equals -16t squared plus 32t. So this equation's already in there. So now I'm gonna put in a second equation and call it 20. And that's gonna be this line right here. Now, when you press graph, you're not gonna see anything because your screen, your graph paper isn't high enough. So before you press graph, go to window and make your Y max, let's say 30. Just so we get above 20. Now hit graph. And what happened? Did you see this? That's not what happened, is it? What happened? Did you see your parabola coming up and down like that, okay? And you saw your line up here. But what didn't happen? It didn't cross. What does that mean? Doesn't get that high. This is the ball right here. Does the ball ever get all the way up to 20? No. So when does the ball reach 20 feet? Doesn't go that high. If it did, it would cross. So it doesn't.
So you just write 0? Or?
No, you say it doesn't. It doesn't get that high. Not, doesn't go high enough. All right, let's get our practice tests out and let's start reviewing, because that's it for the notes. Now, I did start the chapter 1 notes on that same note page, so please don't throw that away. Keep those notes, because we need to start there when we get around to starting chapter 1. All right, so here we go. Practice test that I handed out on Friday. You weren't here on Friday, you need to go back to that bin back there, always. If you're not here, you go back and get your own crap out of the box back there. All right, here we go. Now remember, we're reviewing now, so this is all mixed up. This is all the problems that we've done since school started. There will be one like we just did, but it's later on in the practice test. Right now we what is your strategy for this one?
Make the denominator 12.
Make all the denominators, and here's the tricky part, including this one, all the denominators in the whole problem have to be the same. So we'll multiply this one by 3. She said 12, that was a good choice, right? This one by 4, and this one by 12. Now, as soon as we do that, what can we do now?
Take away the whole bottom.
Take away the whole bottom. So we'll have on top 3x plus 9, that's always a distribute, minus 8x equal to negative 36. So then we combine these. Negative 8 and 3 makes negative 5. And then, here we go, just start solving. So negative 5x equals negative 45, so x equals 9. Are you remembering that from the good old days? All right, B. Another solve. This is a very different kind of problem though. Who remembers how we solve that? Make two equations. And the first one is exactly like the original, except we take out the absolute value bars. But then what do we do with the second one?
We make it a 4. We switch this
We switch this and make the 4 a negative. And since it's a great or problem, we put a little or right there in between them. And that tells me when I solve, I'm probably gonna be solving out here or out here, right? Let's see what happens. I got x bigger than 7/2 on that one. And x less than -1/2 on that one. So I just solve each one, just like regular solving. Nothing hard or tricky about that. Okay, so let's look at it on the number line. Let's see if we can figure out how to write our answer. So here's 7/2 and shaded that way. Here's -1/2 and shaded this way. So what do I put in the handy dandy answer blank right here? All this is my work and it's all really good. You wanna show all your work. But what goes in the answer blank? Josh?
It's like negative infinity to negative 1/2, and then it's well, it's paren.
Yeah, you are right on target. Keep going.
And then infinity, or is it infinity? Or no, it's
Remember, they're in the order they are
Yeah,
in
it's
the
the
number
number, it's the
line.
number first.
Yeah, so it's gonna be 7/2.
7/2, that's okay. Okay, to infinity.
We put a U in between them and that's your answer.
Any helpful ways to remember if it's a U or like which one's and and which one's or?
I already told you, the only way I remember is great or.
Oh, well, I'm saying for the U versus the and or whatever.
Oh, it's never the upside down.
Okay.
We've never done the upside down.
Oh.
Now, the upside down will not show up in an answer. It can show up in a problem, but it'll never show up in your answer.
Okay.
Okay, problem C. Oh, this looks familiar. Why do I say that? Because you took a quiz and you had a problem that looked just like this. Not the same numbers, but what have we got here? This is called a quadratic equation. And how do we solve a quadratic equation? If it factors, you can factor it, you can figure that out. You could complete the square, but that would be really hard because you have to divide by 3. Or you could do what? Quadratic formula, which you hopefully are getting pretty good at. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, everybody okay so far? So -7 plus or minus, okay, now, always pay attention, this double negative means you are going to be adding. 4 times 3 times 2 is 24. So 49 and 24 is, which doesn't break down, so this is an easy one, there's the answer, we're done. Don't have to do anything with it. Josh,
Could I use the restroom, please?
is it an emergency?
Yeah, it is.
Hurry up,
Thank you.
hurry up. Okay, number 2A. New set of directions. This says simplify. Now hold your horses here, gang. The quiz question that we just took had a problem on that looks sort of like this one, except for what? What's different about this one? There's a minus sign in between them. This is not a FOIL. This is a collect-like terms. If it's a FOIL, those two parentheses are sitting right next to each other, right? If there's a sign in between them, you gotta do that sign. So 4 plus I minus 3 plus 2I. Distribute that negative. And then just add them up. So 4 minus 3 is 1, and 1I plus 2I is 3I. There's the answer. Do not FOIL when there's a minus or a plus in between. Now, what about problem B? That one is a FOIL. Does everybody see the difference? Just don't get carried away, pay attention. So this is a FOIL. Which you just did on your quiz, hopefully correctly. Looks like I have a negative 9I in the middle here. And what about this guy? That's actually a positive 2, which means I'm gonna have a 20.
Why don't you bring the I squared?
What?
Why don't you bring the I squared?
I squared is negative 1. There is no such thing as I squared in your answer. Every time you see an I squared, it is negative 1. So this is negative 2 times negative 1, which is positive 2. All right. Which property? Okay, here we go. Part A. Test looks just like this. So do you have to know properties for the test? Yep, there will be 3 questions. Now, they're only gonna half a point each. So they're not like word for whole, like there's a problem, but they're there. Anybody know any of them?
The last one's distributed.
Last one's distributive.
Second one distributed.
Hang on, C is distributive, everybody should mark distributive, C is a distributive. You can always use your notes, but not on test day.
Would one of them be, for B, would it be, order changing, the
No, there's no order changing, it's 4xy, 4xy. What is changing in B is the grouping,
is it these?
the association changes, the associative property of multiplication. So for answer B, you're gonna write associative multiplication. Or you can write it all out if you want, you can certainly abbreviate. So C, we're kind of going backwards here. C was distributive, B was associative of multiplication, and what's A? They're canceling each other out. When they cancel each other out, it's an inverse problem. So A is additive inverse. They cancel each other out. Now, when we went through our notes, we talked about the properties you're responsible for, so you wanna go back and look those over.
For the inverse, does it have to be equal to 0 for it to be inverse?
To the additive inverse, yeah, that's how they cancel each other out, they add up to 0. All right, one more, and I think that's all we'll have time for. 4A, here we go, solve. Whoa, whoa, whoa. This looks like different. How do we do this? Don't you dare say quadratic formula. Can't use the quadratic formula because that's not a square. So done with that.
Would it be when you like add the number over and you do the divided by square thing?
Would it be two separate,
So we can factor by grouping. So if you look at the first two terms, what can you take out of just the first two? Just look at the first two. Take out an x squared. And that will leave you, remember, we're only looking at the first two. That will leave you with an x plus 4. Now look at the last two. What can you take out of them? A negative 4. Now remember, you're taking out a negative 4. So that's gonna leave you with a positive x and a positive 4 because you took the negative out. Now, when we do this process, factoring by grouping, what has to happen? These two have to match, and they do. So we write them down, that's our match. And then we put everything else, so here's our match, I wrote it down. And then everything else that's left over goes in its own parentheses. Now, what do you notice about that? That's the difference of squares. How does that factor? X plus 2, x minus 2, very, very good. So what are the answers to the problem? Look at your parentheses. X equals negative 4, negative 2, and 2. You don't need to put that on a number line. It's an equals.
so the answer we just put, like,
Right here.
negative,
That's it, that's the answer. There's no integral. We only have integrals when we have the less thans or greater thans, right? All right, grab your phones, we'll pick up here tomorrow.